A Chemistry 1 Types of Reaction Lab.
Types of reactions, indeed. We have 5 different types of reactions that we're hoping you can recognize. And we're trying to show you examples of those different reactions in this lab.
On Schoology, we have uploaded a procedure for this lab. There will be 2 documents. There's the procedure that has 5 steps in it. We will be doing these 5 steps. And then there will be a sheet where you'll write observations and you'll balance the equations, identify what types of reactions happened.
Right.
With this.
Right. So basically, you'll be watching the video of this, and then later you can work on filling in the other sheet. So what I'm doing actually, for the most part, is going in order here, but we are showing you step 4 first, just so you can see the before, and then later you can see the after. So step 4 of the lab talks about reacting copper metal, and we have just some copper foil here, very thin sheet of copper metal.
I was looking at the paper. It says use copper wire, but this is fine.
Yeah. I mean, what you basically need is copper metal. And then we're reacting it with aqueous silver nitrate. I don't know how well you can see it.
We can see that, yes.
Keep it in a dark bottle or in a brown glass bottle to keep the light out because it decomposes in sunlight. So what I'm going to do is put a little bit of the silver nitrate into the vial here.
This one reaction is slow. All the other reactions happen almost instantly, but that's why we're doing this one out of order.
Right, so copper metal. This is aqueous silver nitrate. You have silver ions and nitrate ions dissolved in the water. And now we're going to just drop the copper in, and we'll let it sit. As Mr. Moore said, it's kind of slow, so it takes time. So we'll start it first.
Okay, so we'll come back to that.
Yeah, we'll come back to that. Okay, so here is step 1 of reaction 1, which is burning magnesium. Oh, I don't have my goggles.
Top drawer over there. I'll have Mr. Helwood get the goggles on.
Yeah. I had my reading glasses on, and sometimes I forget.
Yeah.
When I take those off, I put on goggles. Anyways, step 1 is to burn magnesium metal. Well, this may look familiar to you.
Yeah.
But we'll run it again just because it's fun.
We wouldn't miss out on the chance to burn magnesium
Right.
a second time.
Okay, you guys are missing out on all the fun of lighting a Bunsen burner. But again, we'll adjust it to get that hottest flame, which basically means I'm raising the barrel and letting more air come in at the bottom. Some of our burners are a little on the wimpy side, like this one. I don't know if we're ever going to get that nice clean inner flame. Should we go for it? See if it's going to light?
Yeah, well, let's see if it'll light the magnesium. It might not.
Yeah. Okay, well, here is our magnesium metal. You may remember from the empirical formula lab.
So we didn't talk about this when we did the empirical formula lab. It's the exact same reaction.
It is. And so we're starting with just magnesium here. Of course, recognize it's reacting with the oxygen in the air. And then we're hoping this burner will get hot enough.
Oh, it looks like it. It's
Maybe
fine.
it will. There it goes. And it's bright.
Yeah. Such a good flame and reaction.
And there's still a little bit of magnesium, well, quite a bit of magnesium left actually. It didn't react. There we go. So we've got magnesium reacting with oxygen.
All right, and there's our product. We started with 2 elements, and we have now a compound.
That's right.
That ash stuff is a compound.
Magnesium, oxygen combination.
Right. Yep.
That's step 1. Okay, step 2 is we're going to heat up. I'm going to leave the burner on for step 2. Oops, did we get a squeaky?
Yes.
Okay, so here we have some calcium carbonate.
Yeah, I'm going to correct you. That's copper carbonate.
Copper, I wanna keep
yeah,
saying
I
copper.
heard you
That's right.
earlier too say that.
Yeah, this is copper 2 carbonate.
Yeah, real nice green
Yeah, it's
solid.
got a
I'm
beautiful
gonna
green color.
hold it up against like the blue in your shirt. We can really see a
Yeah.
color contrast. This is a great compound.
Nice looking stuff. And then we'll put some into our test tube. I think the lab says use half an inch maybe.
Uh-huh.
Put a little more. Should be enough on Mr. Wood?
I think so.
Okay, so we'll use a test tube holder to grab the test tube. And we're going to start to heat the calcium carbonate.
And here's a matter of lab technique too. We normally will heat things sideways. Like you see, Mr. Hevel does not have it straight up and down, it's sideways for even heating. And we normally will aim it toward a wall and not toward our lab partner.
Right.
We
Yeah.
didn't have a chance to go over that kind of stuff, the lab
Right.
safety things, but that's normally the way that we heat things up.
Yeah, in case something were to come flying out the end of the test tube, we don't want to hit the lab partner.
And I understand Mr. Hevel has experience with a lab in Chem 1, I think, going like that,
Years and
wasn't
years
it?
ago, yeah. Test tubes blowing up, it was interesting.
That was a chlorate, I believe, right? You guys were heating up
Yeah.
a chlorate compound? And yeah, this stuff was
Yep.
blowing out of the test tube,
Yeah.
on fire.
It was bad. Actually, it was the most scared I've ever been. That somebody could get hurt.
Yeah, for your students, right? Yeah.
I mean, because literally I said, hit the dirt. Everybody just got down on the floor, and there were broken test tubes flying across the room.
Yeah.
It was not good.
So we see that a change has happened.
Yep. Looks black.
It does. It was green. You can see some of that green up at the top of the test tube. And if I can try to zoom in on the test tube also, this is I don't know if I can get good clean shot. Look at the inside of the test tube.
You see it?
A little bit. Looks like there's some condensation.
Yep. Looks like there's a little water vapor at the top.
Uh-huh.
Now this burner, ideally this would be a little hotter flame. So we're letting it heat a little longer maybe than normal. Now I wonder what the products are.
This is a carbonate compound.
Right. So what we're going to do to test and see, well, what might be in the test tube now that wasn't there earlier. I'm going to take a wooden splint and we'll catch it on fire, and we'll stick it down in the test tube and see what happens to the flame. Okay, so let's try this out. Make sure this is well lit. Okay, very well lit. And you stick it into the test tube, and it goes out almost immediately. Okay, there's the flame. Gone.
Wow.
Okay, so whatever's in here extinguishes that flame.
Yep.
I believe there are some fire extinguishers that operate on this principle.
I think so.
Yeah.
Yep. Prevents the flame from burning.
Right.
Mm-hmm.
I mean, the best hint is if there's no oxygen, there's no flame.
Mm-hmm.
So one thing we know is there's not much oxygen down in the test tube. And whatever it is, I'll bet you it's still there. Right? Whatever it is staying in there because it extinguishes now just as well as it did a minute ago.
Mm-hmm. Okay.
Okay,
So that was step 2.
step 2. This is a little hot.
Yeah, we'll do. You just go ahead and set that down on the tabletop. Let that cool off. Good.
Okay,
So let's leave that burner on again. We have step 3.
step 3 just going to push this aside. It's a little different. Step 3 is to take a piece of zinc metal, and we're going to add it to a test tube, and then we're going to add some hydrochloric acid to it. Okay, so let's get that going. Oh,
That's right. Oh, and you know what? That's a new bottle, so we're going to have to rip up the plastic, I think.
Sometimes when you just uncover it.
Yep.
Okay, guys, so this is called mossy zinc. I always thought it was an interesting name.
Yeah.
It's chunks of zinc metal. I can get a hold of one.
Almost looks like it was at once melted and just kind of dripped off
Yeah.
or whatever, right?
Yeah, it's like a metal. You'd expect it to be nice and silver.
Uh-huh. That's very nice zinc, too,
It
because
is.
we had an old bottle of mossy zinc for a long time. It was a dull gray.
Years, yeah.
And then this is pretty and shiny silvery.
Yeah. It gradually oxidizes. It rusts, basically. It
Yeah.
reacts with the oxygen in the air. Okay, so I've got my piece of zinc. I'm going to drop it in a test tube. And I'm going to add some hydrochloric acid. And you'll be able to see immediately something's going on there. I hope.
Yep. I think we'll have, yeah, it's happening. Well,
Not as quickly as we would like.
no. Almost looks like there's a fish in there, too. You'll see that on the
does.
camera.
That's crazy. I was expecting
It's
this
not
to
a
start
fish.
reacting right away.
Yeah, I think I'm going to have to stop the camera here, and we'll
Yeah.
get a more concentrated
Yep,
HCl.
I think so.
We're not doing so great, so we've gone to the big boy here. We went right to the concentrated bottle of hydrochloric acid, and Mr. Hevel has a dropper full of it, and we're just going to spike this thing, put some even more concentrated HCl in.
Now, I'm hoping the bubbling goes up. Looks like
Yep.
it did, didn't it?
I think it did. I think we've got nicer bubbles. So now we're collecting the gas again. Got the upside down tube.
It was just taking too long. We had a lot of really tiny bubbles.
Yeah, we could definitely see the difference here.
It's bubbling very well now.
Yep. Okay.
Hold on.
I'm going to walk over to this side of you. Yeah, there. All right, let's try this one now.
Ready?
Make sure my camera's there.
It's a coordination test.
Whoa! That's
was
what we were
good.
hoping for, yeah. Yeah.
Hopefully that popping noise came through for you. Now, I don't know if you can do this on the video, but if you can slow it down, I mean, you're actually able to see the combustion going on there.
It's pretty impressive.
Yeah, I mean,
Yeah,
it
when-
happens so fast you can't appreciate everything that's going on.
Yep. The chemistry term for that is a bark. We say that
Yeah.
the hydrogen barks when you light it. It burns fast. It's a very light gas. It's the lightest gas. And so when it burns, it really goes fast.
Yeah, have you ever talked about the Hindenburg in history class?
Yeah, the Hindenburg.
Hindenburg, yeah,
Very
go look
famous
that up.
disaster. Yep.
We haven't ever talked about
Full of
that.
hydrogen. Yep.
Yeah, not the best idea, probably. Okay, we're back to number 4 now, finally, Mr.
Yes, let's check out that copper strip with the zinc. Not the zinc, I'm sorry, the silver nitrate.
Silver nitrate and copper. And if you can see in there, the copper in the solution does not look nice and shiny anymore.
No.
And if I try to carefully take it out,
Yeah, so it has,
coated over
yep,
with something.
yep. Sometimes the solution changes color. It looks like the solution didn't change color on us.
Not really. Not yet, anyways.
Mm-hmm.
Maybe we can leave it in a little longer and see what happens.
So it's the copper and silver reaction.
Right. Step 4. All right, there's one left.
Yep.
Step
This
five.
is a real fast one, too.
It is. So we're going to be mixing together two aqueous solutions. We have lead 2 nitrate, and we have potassium iodide, Ki. And we're going to put these together in a little vial and see what happens.
Yeah, this reaction will not, we won't have to wait for it. It
Yeah.
happens right away.
Okay, so there's the lead nitrate, lead 2 nitrate.
Yep. There's that ionic compound dissolved in the water. It looks just like water. The ions separate from each other.
Now we're going to add a little potassium iodide, Ki to it.
2 aqueous ionic compounds. What type of reaction is going to happen? Whoa.
And that was fast. Isn't that a beautiful yellow?
That's a fabulous yellow.
Now you notice you cannot see through the test tube anymore.
Yep.
So, you know, a true solution where something's dissolved in water, it may have color, but it'll be transparent. You'll be able to see through it. And that clearly is not happening here.
Yes, it's like there's a solid just blocking the light from
Blocking
getting
the light.
through.
There's a solid that's formed. And I don't know how quickly it'll settle, but if we let it sit for a while, gradually we'll be able to see the solid that's in there fall to the bottom.
Yep.
I don't know if it's gonna tell if it's
It
happening
almost
or
looks
not.
like, when you look at it from the top, it looks like the, maybe the sides of this vial are coated. And so we're not going to see it really settle in because we can't see through the coated sides.
Yeah. I don't know
I
how
don't know
well
if
it's
that's the
showing up.
case.
The top is looking like it's a little bit more transparent now.
Yep. I think on the bottom too, right around there, you can see the solid starting to pile up. You can see that with the camera.
So we're forming something there called a precipitate. You mix 2 aqueous solutions and a solid forms. That's precipitation. Set it down. I don't know if it sits for steady if I'm not shaking it.
Okay, well that's our 5 steps.
those are 5.
Yeah, and I think we can see. I mean, you can tell that if we left this sit long enough, most of that yellow solid would fall to the bottom, and we would just pile up on the bottom.
Yep.
The solid's more dense than the water around it, so it falls. It takes a while.
Yeah, we can let it sit here for a while, and maybe in class we can show you the final result. Okay, types of reactions.